Hi. Well, thank you, Felipe, for a great paper and presentation also, because it sort of goes beyond the paper in very interesting and illuminating ways. So let me there were just, I guess, three related points. One was just in the paper itself as written, it seemed to, I mean, this is not a deep point, right? It seemed to toggle back and forth between co-occurrence and like what might be just called a consistent causal contribution. The frequency measure that is in Rupert. And so I just wanted to, sort of inject a word of, caution about that difference, assuming a non-Humean view of causation. And this point will come up in my third point. So the second point was just when I saw the Maud case, and I appreciate the reference to Harold and Maude.
I gave this one.
I got that right away. Yeah.
I gave this talk once, and it just went over people's head and like.
Oh no, it was totally there. It's totally there. So I guess when I first read the case, and I know it's a hypothetical, all that stuff, my thought was, well, why not both, right? I mean, the dripping faucet and her finger. In other words, she could have redundant mechanisms. I've written about the concept of degeneracy and in cognitive systems and so forth. So, I mean, that's a very common concept in there. I mean, in philosophy, it's more akin to multiple realization, right? But the idea is basically, the answer that popped into my mind was the one that you didn't give, which was both, right? I mean, she has both of these ways of doing it, at that particular time. So I wasn't sure why.
Well,
that answer
happened. So it turns out that.
So let me just I'll just wrap up my sort of comment.
Okay.
So there's this issue of redundancy or degeneracy, which also extends over time if you include plasticity. And then at the very end, and this kind of goes to the stuff that you're doing at the very end, where you're extending it to new network science and things like that, and new results. I was just at a Brain Day conference with Olaf Sporns and Brian Knudsen and, people who do network stuff. And, there was a great deal of gnashing of teeth about the fact that, a lot of claims about functional connectivity really aren't about causal relationships. They're just co-occurrence statistics, right? So you get a blob here and a blob there, and, they both light up at the same time. And so this kind of goes back to my first point, which is to be careful when you're doing some sort of a, fMRI-based or, network analysis, that you are, in fact, you're getting co-occurrence, you're not getting causal relationships, right? And the criterion is about the causal relationships, right? So, ultimately, I think your point that, first of all, the idea of frequency, right, of causal relation, right, consistent causal contribution is going to be implicit to some time frame, right? That's clear, and I think it's kind of, so I sort of see your emphasis on the temporal dimension as more of a elaboration or friendly amendment of Rupert's criterion, because even if you add the temporal dimension, make explicit the time frame for measurement, and of course changes over time, which would just induce degeneracy if you don't already have it. I don't see how that is, rejecting the idea that you still want a causal connection that is above a certain threshold for it to count as a causal contributor. So that's it.
Okay, good. 2 points. Yeah, I mean, this could be a friendly contribution or amendment or suggestion. I don't think that we have to throw everything about the integration system, because a lot of that makes sense. So two points about why not both. So here's why I don't think both, because it turns out that in addition to the dripping faucet, then there is this other, I don't know, like think about any a weird mechanism that is in a possible office where she could spend an enormous amount of time. So there's n possible things that could just have the exact same frequency of sound that the faucet has. And why wouldn't these possible mechanisms also be included within the cognitive system? I feel that if you open the possibility of these two mechanisms, so this both the finger and the dripping faucet, both of them being part of a mechanism, why don't you open up the possibility for any number of them to be part of the cognitive system?
Right.
At time t1, when she only could do it with the finger, was at that time t1 the dripping faucet part of the cognitive system? If you say yes, then you open the possibility for any number of mechanisms to be part of the cognitive system, and I don't think that that's a good thing.
Right. So this seems to me to add, to his conditions, the idea that, well, if you really want it to be a causal contribution, it has to be in some sense, you don't want a distal cause, you want a proximal cause. And that just seems to be like, that's another dimension of the debate that, I've sort of just set aside because he doesn't talk about it, but obviously Aizawa, those people are talking about that. But that seems to me to, kind of bring in another issue of proximal versus distal. And, I kind of just set that aside. So I don't, if you add that, fine. But that wasn't the issue that we were talking about. We were talking about time.
Wait, no, but I thought that was part of the issue because, so in that since there is also this diachronic change in mod, then you have to figure out. So I would find it very strange to say that the dripping faucet was part of the cognitive system of mod prior to the accident, but I would have to say it if both are part of her cognitive system. That's what I find strange. But now, to your second point of co-occurrence, I agree with you about the issues of co-activation not being necessarily causal. And as I mentioned in the paper, I'm using here kind of like an idealized sort of model of what an fMRI does, because I know that fMRI is only, correlational. It doesn't really find any causation. But more importantly, co-activation of different regions in the brain is, for the most part, only co-activation. So there's another talk that I could have given about what's a brain network, because as a person that does fMRI and does a lot of connectivity analysis, I don't all the time think that my analysis are bringing out networks, despite the fact that I can model them topologically. What does this mean? It means that if I want a network to be something like a biological functional unit, as people say, for instance, the default network is, or the frontoparietal network is, then you need to have a story to tell as to why is it that these things, by the sheer fact that they are coactive, nonetheless form a structure that have a particular function or that evolve for something. So this is one of my concerns with the notion of network. And oftentimes our analysis do not provide us that evidence. So here is the worst kind of way in which you can do a network analysis, by using, and people sometimes use the notion of network in the following way. You use a univariate analysis, and then there is two distant regions that both survive a very stringent threshold. And then people say like, oh, look, these two regions are both active in bringing about a particular task, so the two regions form a network. That's horrible. That's not true. It might be completely possible that the two regions have entirely different temporal dimensions. They both were fitted to the hemodynamic response function, even though if you were to take them individually, they will come at different times. And there is no reason whatsoever for thinking that they are correlated. So another possibility is to run some sort of correlational analysis, is that in addition of these two being coactive, you take individual changes in blood level oxygenation, then you look at whether those changes are covariant in the way of which, they are both correlated in their change, and then you have something like a correlational analysis that is just the basis of connectivity analysis. That's great, but still you have no idea if these two correlations have anything whatsoever to do with one another. So people are suggesting that not even with this kind of connectivity analysis, we're supposed to be talking about networks, that in reality you need even further evidence, namely evidence about connections between this. So physical connections, there should be a tract, there should be, axons connecting one thing to another. And then we get into things like DTI and tractography and things like that, which are also very complicated because it turns out that doing a DTI and knowing exactly how they are connected works for certain fibers, but in other fibers is complicated, particular fibers in which, because of issue of how tractography actually works, that you don't know exactly how to resolve when fibers cross one another. So there's algorithms to try to come up with the best solution, but I think that there's a lot of controversy in the field as to how to do it. So there are gaps in this connectivity. And even if you have connectivity, you don't even know if in what direction, as it were, the information is flowing. So people use some strategies like in using ICA or things like that in DTI, but at this point we have such level of idealization that it is unclear whether we're actually finding causation as opposed to imposing a causal model onto some relatively noisy data. So I agree entirely with you. And this paper is kind of like philosophical in the sense that we have here like an idealized fMRI, but in practice there is an enormous amount of difficulty on really seeing to what extent the data from fMRI really tells us much more about causation. So I'm cautious about that, and I totally take your point.
So thank you so much to Fabrizio for inviting me, and to Felipe for the great talk. I really enjoyed the paper and talk. I'm especially glad about the network solution he proposed, because when I read the first half of the paper and then Rupert's proposal, it seemed wanting of a more nuanced understanding of how to measure network connectivity, and so the proposal with respect to how to cluster nodes together within a network seemed like the exact right place to push that in. So that I was extremely glad to see that Felipe was absolutely suggesting that this is the direction in which that kind of work should be going. But I think I want to maybe jump on or repeat or expand on the point that the point 2 that Carrie made, I believe, that why must there be a cognitive system in an individual across their entire lifetime that causes or realizes, wherever you want to put that language, whichever task we're interested in studying. I mean, and in particular, if we look across individuals, why should we think that we're going to have a homogeneous sort of cognitive system that would be able to bring about that task, as opposed to expecting that there might be some heterogeneity in the cognitive systems, such that we could talk about there being different cognitive systems, and what we might be required to do is simply time index which cognitive system at which time for which individual is the thing that is causally responsible for the performance of whichever task we're interested in. And why should we not want, for what reason would we want to be cautious about accepting that result? And I didn't see any reason why the example of the dripping faucet and the finger tapping would motivate us to be cautious about simply thinking that a variety of cognitive systems at different times that were clustered together were each responsible for that instance of the performance of the cognitive task, and that for what reason would we not want to be accepting of that result?
Yeah, good. That's good. I mean, I'm happy being as revolutionary as you want. The problem is that notice the things that we would lose, which could be fine. But so think about the principle of double dissociation.
Mm-hmm.
It's a very important principle in neuropsychology. People still use it in cognitive neuroscience. And the suggestion of double dissociation is that you start off with the assumption that there is something like a stable system that produces a particular result A, and there is another stable system that produces a particular result B, right? And you knock down one, and then you don't get A, but you get B. You knock down the other, you don't get B, but you get A, and you make a conclusion to the fact that those two are entirely different systems because you expect some degree of projectability from there being systems onto what they are going to do in the future.
Mm-hmm.
If you temporalize cognitive systems now, then double dissociation is going to get really, really tricky, right?
Mm-hmm.
So this is one concern. I mean, again, I might not look as revolutionary as I should, but I am very happy dropping the notion of cognitive system altogether. But notice that doing so has some implications, many methodological implications. I mean, I'm gonna so this goes back to when I was in grad school. When I was in grad school, I taught a class. It was I enjoyed that class like a lot. It was a class on a sort of philosophy of cognitive science, and we started reading. It was kind of historical introduction. We read very classic papers in which certain foundational concepts in the discipline were introduced. Cognitive system is one of them. I mean, you see it even before Atkinson and Shiffrin. In a way, you see it even before the origin of cognitive science. And they are completely foundational. And in this class, we read all these papers, and many of the papers suggest that certain concepts like representation and concept were essential. Now, obviously, we do cognitive science, and we think that we can do away with concepts, that we can do away with representation. So why not thinking that we can do away with cognitive systems? So I'll be happy with that kind of view. But the reason why I think that I have to be cautious is because getting rid of the notion of cognitive system is methodologically risky. It plays an important role in the way in which we go about conducting cognitive science. It plays an important role in the way in which we make predictions about what we should expect, even certain manipulations and so on. So that is why I am cautious. Maybe in the future I will give you an alternative, but right now I think that it is doing some good service for us.
Can I take a quick
Yeah.
follow-up?
Yeah.
Just a quick follow-up, though.
Okay, so I guess with respect to the double dissociation, I guess my worry is that it's not a double dissociation because we've kept the task continues to be present. So we only have the dissociation at the level of the causal system responsible for it, but we don't have the absence of the task. So it doesn't, for the examples that we have, it doesn't look like we get a classic double dissociation. And I guess with respect to the cognitive system, I guess I didn't take myself to be advocating the radical rejection of it necessarily, but perhaps a weakening or a new interpretation of the ways in which we would individuate cognitive systems, and that those would involve sort of some type of temporal instability as opposed to taking them as being stable across a lifetime. And I didn't think that was as worrying or revolutionary as the methodological suggestion you've made, and I hadn't thought about the methodological worry, so perhaps I should think more carefully about what would be lost if I was too willing to give up.
Yeah, I mean, I'm very sympathetic to that view because so I was trained as a cognitive scientist and a cognitive neuroscientist, and I felt that my demands for making claims about a cognitive system were really high. Like and you see this in a lot. Like people say, like, well, you cannot really talk about a system. So people talk about processes instead of different processes, and like it's just kind of like right. But then you see other psychologists talking about cognitive systems all the time. There is an abstract system, and you go like, wait a second, if this is a claim about cognitive architecture, if this is really a claim about how our minds are structured, right? Then it seems as though you need much more than your difference in p-value with a between group experiment to say something about how the mind is structured. So I think that there is a sort of a promiscuous use of the notion of cognitive system, and we should have reined it in. And this is something that you're suggesting too, that maybe our standards of when is it that you have a cognitive system should be recalculated and maybe put a little bit higher.
So Felipe, thanks so much for the paper. And I also wanted to say really quickly, it's only recently become clear to me the full breadth of what's going on in your guys' lab, and it's just awesome. I mean, I'm like incredibly jealous. But
I have intellectual ADD. I get like a gazillion different things, and I have I've been supremely lucky.
Well, it seems awesome from the outside. So, but I also really liked this paper, and I found it really really interesting for a number of reasons. I guess I have a couple of questions that are maybe around the periphery. I'm not sure. So I'll just sort of put them out there, and you can maybe engage with it, whatever you think is most interesting. So one kind of low scale thing is to what extent the age-related changes really precisely map on to the Harold case as you describe it. So the only one you list where there's actually a difference in areas is the laterality thing, and that's, I mean, it is a different area, but it is a laterality. It seems largely overlapping prefrontal areas in the two cases. So, and then the other case was not actually a difference in which areas are involved, but I guess the degree to which they're involved in the particular task.
You actually get to lose the area, as it were, because you can have, so the anterior, I didn't get too much into details, but suppose that you get activation in, parietal, posterior parietal, and then just a weaker activation in prefrontal, and then you actually might lose the posterior parietal and increase the prefrontal. So, I mean, it's something.
Oh, I see.
Because notice that with fMRI, this is another concern. This is an idealized fMRI, which, and this is one of the reasons why I hate univariate analysis so much, which is that we are not seeing activity forces us to interpret null hypotheses that have not been rejected as if
right.
they had been rejected. Do you see what I'm saying?
Yeah,
Lack of activity in parietal cortex when I see prefrontal cortex highly active doesn't mean that the parietal cortex is no longer active when I'm seeing the prefrontal.
Right.
So this is kind of like an idealized
Gotcha.
MRI, if you want.
Okay, fair enough. That's helpful. So then two maybe slightly more substantial points. The one is that the thing about strategy didn't go quite over for me. So you tended to present strategy as though it was sort of a conscious strategy or something like that. I take it what's probably more relevant here is sort of an information processing strategy that's being employed by the relative brain areas. So Aizawa talks about this in one of his multiple realizability papers about how you could get different types of functions even within the same localization. And indeed, if part of what's going on in the frontal to the anterior to posterior thing is compensation, and you bring that up later on, then one natural way to describe that, for me anyway, is to say, well, there's a different strategy, maybe having a more abstract frontal representation as opposed to a more detailed posterior, or something like that, right?
Yeah.
No,
I hear it. Yeah, go ahead.
And then just the last point, I think, going directly off of Carrie's, is, I was a bit worried about, so I like the advance with doing the network connectivity. I'm wondering about whether it's got a limit into how far it can take you about this, right? So if you don't want to say it's all part of it, right? It strikes me that in the mod case, for instance, you're going to get slightly different networks, and then we're going to be left with something like the same question, which is exactly how much do we fit in, right, to the cognitive system. And it seemed to me that one necessary step that maybe the network analysis won't get us to is to really carving up the operations that these different areas are performing in these, are some areas performing the same operation in these different tasks and so forth. So I want to know whether you think that step will also be necessary at some stage to figure out some of these questions, or whether we can get there just with the network analysis.
That's a great and difficult question. One thing that I haven't thought of, and that is definitely brought up by your question, is whether we would lose the notion of decomposability if we think about networks in this weird way. So if a network is, if I think about dynamic networks in a high dimensional space, in which it is not very clear how it can be further decomposable into non-dynamic areas, that might get the idea of functional decomposition tricky. I think you're very right about that. It's something I need to think about more. Yeah, I don't know exactly how to answer that question. And what was the previous point that you were making?
Oh, sorry, about the strategies.
And the strategies. So the strategies is interesting. There is this huge, I mean, it's a big discussion that goes on in the aging literature. There seems to be very clear cases of different strategies that people might be unaware of, right? So I'm going to give you an example, one of my favorite examples from neuropsychology. When the arc fascicle that connects Wernicke's area with Broca's area gets broken, people cannot repeat. That is called conduction aphasia, and it's very. If I ask you, hey, repeat after me, you just won't be able to do it. It's a very interesting sort of phenomenon. People can learn to repeat by doing sort of atonal musicalization, right? So they can sort of circumvent the breaking of the arcade fascicle and employ something like an atonal musicalization to repeat. And eventually, they just do it, it's natural for them to do it, and they are essentially indistinguishable. This is part of the phonetic therapy that individuals with that kind of aphasia undergo. So that seems a very clear case of an entirely different strategy to perform the same task, right? But often, so I think that there are very clear cases of different strategies. That's one, and I would never say that it isn't. But there are often cases of tasks that seem to be recruiting different areas in the brain as a function of aging that is just, I don't know exactly what would be a different strategy. So pop-up effects and attention. So you see, reduction in asymmetries in pop-out effects of attention. What is another way in which you can do a pop-out effect of attention? Like you just do it. It takes 400 milliseconds to do the pop-out effect, and you got. If you had, I just don't know exactly what is two possible strategies. So the way in which people say is by sort of reversing the order of explanation. They see a difference in the brain, so they infer that then the brain must be doing some different kind of strategy. But coming up with exactly what is another strategy for doing pop-up effects is very difficult for me. That's the default answer for many of these asymmetric or many of the differences that you see in aging. You say, oh, it's a different cognitive strategy. But you push aging researchers to try to tell you, well, so what is that other strategy? And often they don't have an answer. Yeah. So I agree that there are very clear cases of different strategies, like the one I gave you at the beginning. But I think that that in some other instances, there aren't very clear cases, and I think that it's just our theory pushing us to say that everything is a cognitive state just because we see a difference in brain activation.
Yeah, so just really quickly, I'm totally on board, for instance, with not being willing to take this hyper, deliberative cognitive concept like a strategy and just glue it down everywhere. I totally agree. It seems that there's going to be a sort of continuum between very deliberative stuff and just pure brute broken associations that get you the difference. Maybe that's the kind of task you're describing. And then there might be some complicated middle stuff where it looks like it might be something like a strategy or something like that. So,
and I agree with you. It might be possible that there is. So suppose that in the case of the individual with the conduction aphasia, suppose that individual just is not aware at all of doing anything differently, right?
Yeah.
So yeah, the cognitive strategies, there are like 3 levels. I think that there are different cognitive strategies that you can be consciously aware of employing differently. There might be different cognitive strategies that you cannot be aware of doing. But I think that there is a sub-level in which you don't even know what a different cognitive strategy may be. And those are the ones that I think like you still get the effect, but you don't. It's hard to see what a cognitive strategy is.
Yeah, sounds totally right to me. Right.
Okay, cool.
Thank you very much for inviting me, and thank you very much for this talk and your paper. I really enjoy your view traveling across the different research fields to collect ideas and arguments. And I particularly like the fact that you bring this neuroscience of aging into the question of cognitive ontologies. That's really interesting. And also thank you for your nice introduction and summary of network neuroscience. I mean, you really made the basic concepts accessible to a large audience, I think. Yeah. So I've been through your argumentation, and I have many points actually at which I stop and I start considering a completely different view. So the first one is that basically you make all your points about the fact that the brain change across time, and I would make also a big point about the brain are not only dynamic, but they are also different. So basically, when you start your argumentation and your formal definition of the concept of integration, you start by saying, given a specific, in a given specific subject. And I was wondering, that may be a trivial question, but why do you start there? And basically, all the argumentation that you make about the fact that the brain changes and how it can inform us about cognitive system, you could have exactly the same argumentation with the fact that not about this diachronic variability, but just the interior variability. So basically, if, for example, even your concrete example about the Maud case in which she has this finger on the one hand, and on the other hand she has the thin triplet, you could have the same argumentation or the same or similar view just considering 2 different individuals. So if you just look at me and you, for example, I might use the finger and you might use the thing, and before actually looking at change across time, we could also just look at change across individuals. So
yeah, that's absolutely right. I mean, one of the most one of the things that we do, for instance, in aging is that, as I mentioned, aging brains change through time, and as a result, co-registering brain scans onto one template becomes tricky. That is to say, making different brain scans of different individuals make them dimensional so that you can compare activation across different individuals is really, really complicated, because as we age, not only the brains become more different from how the brain was when you were younger, but they also the differences between individuals start being larger and larger and larger. So in other words, it might be possible that the cortical mantle gets reduced more so in one individual who's 60 relative to another individual. So even in fMRI, the amount of like idealization of your data that you have to do so you can sort of co-register it across different brains is trickier than even with younger individuals. But even at the like pure morphological level, you can see huge differences across individuals. One of my favorite very like robust macro differences in cortical organization is the Hirsch gyrus. So the Hirsch gyrus is in the tip of the temporal cortex, and some people have one, So this is a gyrus. So people have 1, some people have 2, some people have 3. So that we're seeing brains that have entirely new circumvolutions in one individual and in another individual they don't. How do you do that? This is like, I mean, that's a lot of real estate that is different between certain subjects. So if you're looking at, area, the tip of area 22, which is part of the Hearst gyrus, one individual has 1 and one individual has 2. That seems like entirely different regions. We co-registering and looking at like averaging across those individuals is going to just be masking an enormous amount of variability, right? And we do this over and over and over again. Now, one suggestion is, and you have said this recently in your TICS paper, is to use big data, so that then you employ large amounts of fMRI data, so that some of these cortical differences get sort of averaged out, right? And then you end up with something like an ideal distribution of probability of activation in a particular voxel that might or might not fall within your hash gyrus. But so I take your point entirely. Not only there is diachronic dynamicity in one single individual, but there is across different individuals. To this point, and related, this might be of interest to you for your interests as well. So there is this cognitive neuroscientist of memory, Mike Miller, who has developed these strategies for analyzing individual differences. And one of the things that he's shown is that your brain is more similar to your future brain doing the exact same task than it is to individuals of your exact same age doing the exact same task. And that should be worrisome, right? Because you should expect to see the same level of reliability across other individuals and yourself doing a particular task. How do you account for that variability? How do you account for those individual differences? If those individual differences become significant, then can you even make generalizations across people your age? So that point is taken, and an entirely different paper should be written about dynamic, not only diachronically dynamic, but also contemporaneously dynamic brain systems. So I take your point entirely.
Okay, thank you. I had another comment. So when you bring the argument on the changing brain, so if I think I understood that you kind of directly consider by bringing this aging, this studies in aging as argument that change of brain individual structure are evidence of changing mechanism. So if a subject in time 1 and time 2 recruit different brain structure for the same task, it means that he has engaged different cognitive mechanism. So this is your point. And I was considering a completely different view, which is not intuitive and which is not the most common one. But if we start dissociating brain structure from cognitive mechanism, so we would, for example, consider that two regions, region A and B, let's say, for example, in the frontal cortex, and they are bilateral homotopes, so region A is on the right side and region B is on the left side. And we consider that they actually do the same type of mechanism. They do exactly the same type of mechanism, but on different type of representation. So region A process representation 1, and region B process representation 2. And then with aging, there are structural change, and region B, for example, will have some gray matter volume loss. And so there will be some functional reorganization. And region A, therefore, would kind of take over the different type of representation. Norwegian A will support process representation 1 and representation 2. So then you have to interpret the result in aging completely differently. You cannot take as granted that brain change in brain individual structure are recorded are evidence for different mechanisms. You know,
Well,
they could be the same mechanism, but just reorganization in terms of representation, which could be the case in frontal region, I think.
Right. So if I understand your point correctly, I think that part of what happens is that then we will be sort of equivocating on the way in which we use mechanism. One thing that I think you are trying to say is that, well, maybe what we should take as mechanism is the computation that this particular brain region is doing, right?
Yeah.
You might say brain region A and brain region B are, you know, in the younger adult, brain region A does a particular computation P, and then as we age, turns out that there is other brain region that gets recruited, but the computation hasn't changed, right? They are both now are doing the exact same thing. That's fine, but then we are finding a difference between computation and mechanism. So, well, and which is perfectly fine. You can define mechanism differently. In philosophy, there is all this tradition of defining mechanisms in terms of activity, like parts and activities that are developed by those parts. So it might be possible that you want to say that the actual unit of explanation is the computation rather than, which I think you want to say, that rather than specifically the area. In addition to that, there is a further question as to what's a brain area? You know, brain areas are, we have this idea that brain areas are very easily identifiable geographical spaces in our brain map. But brain areas are definitely not at all like that. So you have all sorts of different kinds of functional parcellations that end up giving you certain answers where the cortical the cortical structure is clearly divided. So you see in occipital cortex columns, you know, across the cortex that are very clearly sort of segregated, separated one versus another. So you even cytoarchitectonically, it seems pretty clear when one area differs from the other. That's the minority of the brain. Most of the brain neurons are like this, so, you know, neurons in one area end up in another one, and then what you have at best is a probability distribution of where on earth this voxel ends up occurring. So, in fact, my sense is that in cognitive neuroscience, there is an evidentiary use of brain area, and there is a phenomenological use, phenomenologica in the sense of philosophy of science, of what the scientific phenomena is, of use of brain area. And the way in which we, cognitive neuroscience, use brain area as evidence is just basically saying we have, it's a distribution, it's a probability distribution of a voxel falling within a particular area, rather than saying something specific about the geography of the brain. So to sort of conclude with your point is, I agree that we have questions about what exactly a brain area is. It might be possible that instead of thinking about of identifying brain area with brain mechanism, that basically what maybe the best strategy is to identify what is the computation that a particular brain area does, and then we wouldn't have to make all these machinations, because it turns out that A and B are both actually computing the same computation, right? But if that was the case, then we'll have to think very hard what exactly we mean by mechanism, and which is possible, but definitely would be a different notion of mechanism than the notion of mechanism I was employing.
Yeah, I'll try to be quick then, since time is short, but there's a ton of things happening in my head because of this paper. So I'll ask one pretty small sort of empirical question, and then one I take it to be greater sort of philosophical or conceptual question. The empirical one is that there is a a set of research linking bilateralization to difficulty. So in sort of, like neurotypical adults, there are lots of cases where an easy version of a task seems to have a big hemispheric asymmetry. Like a vigilance task could recruit the left hemisphere more than the right, but that once that very same task becomes more difficult, then the asymmetry sort of goes away, and both hemispheres appear to be engaged. And some of Todd Graber's work here at WashU suggests that things like that go on. So I was just curious, in connection with the Herald model with increasing.
Yeah.
With
That's a possibility. The problem is that difficulty normally is measured by, say, increases in reaction times and some behavioral differences. And then the Herald you see even when there is no difference in reaction time.
Cool. Okay. Yeah, that's really interesting. So that was the small point, and then
one thing though is in aging research, often you have to control for performance, right? Because it might be possible that older adults have like a harder time seeing something or a harder time hearing something. So you sort of slow down. So it might be possible that there's some difficulty that is masked as a result of that because you're making them way too easy so you can equate performance. But I think that even in tasks that like are equally difficult or equally simple, you're going to see the Herald effect.
Okay, yeah, that's great. And then, so the bigger sort of more conceptual question is what, so I actually agreed with many of the points in the paper and the need to look at the dynamic brain, but I wanted to ask what, what aspects really speak to the issue of cognitive ontology. So when, like Russ Poldrack's Cognitive Atlas, project, there seems to be this goal of taking, complex human behavior and finding out what the periodic table of the mind picture where we're finding out what sort of basic, processes are, characterize the mind. So, instead of memory be fractionated into working memory and episodic memory, and then we have sort of these taxonomies psychologists are developing. And I'm just curious, but it didn't seem like the claim was really that people who are aging have like cognitive capacities that are of a different taxonomic sort than the cognitive capacities that younger individuals have. And so I'm curious about what connections from that the brain is different and that, to the sort of taxonomy that psychologists develop is really going to need to be different for the aged brain.
Yeah. So I guess I wasn't thinking so much about like whether there are different categories as a result of aging, but rather of the project of doing something like what Ross is trying to do. The idea is that here's what I was afraid that it could happen: that you come up with this amazingly beautiful fMRI data, which is all based on TRs of 2 seconds and all based on tasks of a few seconds long. And then you have your categories, and then you do your magical mapping from one onto another, and then you end up with something like a mapping from categories, whatever they are, to certain brain areas. And then you go like, oh, look at this. It turns out that brains change through time. And in addition to that, it might be likely that there are certain cognitive categories that we employ here that actually occur at a different temporal at a different temporal scale than other tasks, right? So autobiographical recollection is something that we know. So cue recalled autobiographical recollection is something that we know requires in the order of 3 to 4 seconds. Attentional blink is something that we know occurs prior to reentrant activity in occipital cortex. So it has to happen between 150 and 700 milliseconds. Those are 2 different temporal scales, entirely different temporal scales. And one concern that I have is if you don't take into account how long it takes for a cognitive process to occur, and even more worrisome, if you only take into account static fMRI data and don't look at how the data how brain activity actually fluctuates through time, the mapping that you do with your ontology, even if you get your categories right, whatever you're mapping onto the brain is probably going to be incomplete, inaccurate, and maybe even possibly wrong. That's the connection.
Yeah, great. And so I just wanted to distinguish because it sounds there, which I think is absolutely right, that the empirical project of making neuroscience relevant to the taxonomy of psychology absolutely has to reckon with this problem. And I think that's awesome. And then but that's different from the other claim that maybe it's true actually that aged brains have different kinds of cognitive.
Yeah,
I was just trying to distinguish those sorts of considerations.
That is a possibility. That is a possibility. I wasn't considering that side. I was considering, but hey, you might be completely right. It might be possible that the only way in which we can accommodate some brain changes through time is by just basically adding a new category. And then like older adults are going to be able to look at younger adults and like, you cannot subitize X the way in which we do because you're too young. Or maybe wisdom. Wisdom is a category that you don't have until you reach a certain age. That's a good thought. I hadn't thought about that.